So I'm taking the combustor of length 100 mm, height 10 mm. Then from the inlet at 10 mm distance, I'm injecting the fuel. Okay, so we will give different injection angle to the students. Even sometime we will give injection from both side. Okay, this is the air inlet and this is the fuel inlet. This configuration also we will give. Now in this setup, so this line you will define as the air inlet. This one you define as the fuel inlet. Remaining etc. and all wall. Now this will be outlet. Okay, remaining etc. wall. Then for some students we will give injection on both sides. This also they should take it as a inlet. Okay, there can be a 90-degree injection or 60-degree injection like that and all. We will change it. Okay, setup is clear, right? The domain.
Yes, sir.
Okay, and this blocking is must. Okay, 1, 2, 3. This blocking is must. What will happen if you don't go for the blocking? For example, 10 mm, then another one small line for 2 mm, then 90, 88, 88 like that. If you create, when you import it, software will do some cleaning work to this geometry in that time. So it will consider that as some gap. It will fill it. It will consider this as a single line. Okay, software will do some cleaning work in that time. It won't consider this 2 mm gap. It will convert that into a single line. So that type of issue will come. So always you can go for the blocking. Okay, this is just 2 mm. So I have went for the blocking of this combustor. Then, for example, I am taking air here, oxygen plus nitrogen with a velocity 100 meter per second, and I am taking temperature is 650 Kelvin. Okay. Then from here, I am taking the fuel. You can take any combination, hydrogen, methane. So all this, anything you can take it. Methane, ethane, propane, butane, any combination you can take it. Okay. For example, I am taking the simplest one, hydrogen. Okay, and always compared to the air velocity, this velocity will be less, so I am taking 3 meter per second. Okay, fuel velocity, and fuel injection velocity temperature is 300 Kelvin. Like that I am taking the boundary condition. Is that clear? Air plus hydrogen, velocity, temperature of both air and fuel. Let me design with a 90-degree, or I will show how to give 60-degree also here. So first you have to create this rectangle, then you have to fill it using the wireframe and surface design. Once you filled on this sheet, you have to draw this rectangular profile. Then you can do the split option. Then you will get 3 different domains. This procedure you know that, so I am skipping this procedure. So this is one way of creating the combustor domain. Then next method, like this, in many paper you could see there will be another one projection for the fuel injection. This way also they will create it, combustor domain. Same thing, 100 mm, 10 mm height from 10 mm for 2 mm length we are injecting. So previously I said, so here, so this is my reference line for example. So if I want to give 45-degree, then I will give x velocity is cos, that is x component is cos 45, y component is cos 45. Additionally velocity I will give it. Okay, only one line. If I want to change the angle, I will change the x and y component. Okay, sin theta, cos theta, that I will change it. This is one. Okay. So this is one way of changing the injection angle. Okay. Otherwise, depends upon the injection angle, you can draw this profile additionally. Okay. So for example, here I have taken 45-degree. Okay. So this line and this line I have taken 45-degree. Okay. While drawing itself, there is some small projection. Now, what is the easiest thing is, if you are going for the fluent, I don't want to define x and y component. Simply, I can give normal to this boundary, the default one. Okay, I can define velocity inlet, then normal to boundary. So either you have to define XY component in the fluent, otherwise in the design itself you can incorporate the angle, injection angle. Is that clear? Both method?
Yes, sir.
Okay, so here I
Yes.
can give normal to boundary in the fluent. I no need to give XY component and all. So two types of setup. So anything you can follow. So I am taking a simplest reaction. So oxygen plus hydrogen. Uh, the main product will be the H2O water formation. So instead of hydrogen, you can take any combination. I will show you how to include the other components instead of hydrogen. Then in the fluent setup, it is almost same. Only two steps are different. In the model, usually we will define energy and viscous models. Okay. Additionally, this species also you have to define. In the species, if you open this window will be opening, there you have to change these three. Okay. Additionally, you have to define the species there. These three you have to change it. Whether it is non-premixed, premixed, those things you have to change it. So we are injecting air and fuel separately. Okay. So this is non-premixed. Premixed means this mixture we will inject. Then partially premixed means air, then fuel air combination. Both will go like that. It depends upon the application. You should choose non-premixed, premixed, partially premixed. Then in this boundary, you have to define the reactant you are taking. See here they define the air. Okay, this default value it will be there. Okay, so 78% of the nitrogen, 21% of the oxygen. So this default value already will be there in the software itself. Only that fuel you are taking, that you have to define it. For example, if I am taking hydrogen, then I should give 1. Okay, or if you want to add some other component here, for example CH4 etc., using this library you can include. Simply I should type CH4 add, so that box will be coming here. Okay, another one box will be coming with a CH4. Then there I should give 1, remaining fuel column should be 0. Like that you can add any fuel. This also I will show it in the software. So this is the first step, selecting what type of combustion. Then second step, defining the boundary. Then third step, table. In the table, what you will do, simply you will click on this calculate PDF table. So what it will do, so whatever the reactant we included, air plus hydrogen, for that, so there is some library. Okay, it has around 400 something reactants, and products will be there in the ANSYS library. So it depends upon the reactant combination you take, it will add the remaining products. For that you should press this calculate PDF table. So all the products will be imported in this ANSYS. Okay, this is the third step. Is this clear? This is first, second is boundary, third is table. These three steps are new. Then he will define the velocity inlet for air and fuel. First he will define the velocity for air and fuel, 10 meter per second. Here 3 or 5, anything you will take it. Then we will define the temperature, same inlet only. Previously we defined the momentum, now we are defining the temperature. 650 Kelvin, here it is 300 Kelvin. Then third one, species, momentum, thermal, then third one is species. So by default it will be 0. We won't change it for the cold flow analysis. Okay, for example, if this is the duct, so here I'm injecting some air, here I'm injecting some other air or gas. Okay, simply both are mixing and I want to see how the mixing happens. So in that cases and all, this species we won't disturb. But if there is a combustion, then that fuel you should give 1. Okay, if the 1 is not defined, the software will take everything as the normal fluid. Okay, so instead if you define 1 in this main mixture fraction, the software will take that as the fuel. Okay, if you don't define 1, if you simply keep it as 0, software will not take this as the combustion analysis. Simply it will show some mixing property between these two fluids. That's it. Is that clear?
Yes, sir.
So by giving one only, we are telling the software this is not simply a cold flow. We are simulating the combustion. So this is very important. So along with the thermal and momentum, this phase is also important. For air, we don't need to change it. In the fuel, the main mixture fraction should be 1. Then only combustion will happen. Otherwise, simply what you can see is the some mixing flow of cold flow of this fluid and this fluid. That's it. These two only different. All other things are same. Okay. So this species is different. Then here species is different. All other things are like a normal simulation flow. Is that clear?
Yes, sir.
Okay. So at last you can find how whether the combustion happened or not. Okay, by checking the temperature and all other product etc. and all. Okay, you can go to the contour, temperature etc. and all you can find it. But if you want to find the reactant product etc. and all, again there also you have to go to the species. There you can find mass or molar fraction of H2O2, H2O, everything. Okay, we will check static temperature. This is very must. Okay, if combustion happen, what we have taken is 650 Kelvin air, 300 Kelvin fuel. Both will combust and the temperature will go up to 200, 2000, 3000 Kelvin. Okay, if combustion not happen, that is in the main mixture fraction, if you don't define one, what will happen? Both will mix and average velocity we may get 500, 600 something. Okay, that means combustion is not happening. So the temperature will be nearly 2000 or more than 2000. Then we will check the contour for H2O2 reactants, then products of H2O and H radicals, H ions. The importance of this H is we can see where is the flame core. Okay, for that these 5 we will find it. Okay, so here this is the temperature you can see. Maximum it reached 2219. But what I have taken is 650 here, 300 here. Okay, if there is no combustion, this flow will mix so that I may get only 500 to 600 Kelvin. Due to the combustion, it reached 2219. This is the first step you can verify whether your simulation is correct or wrong. And this is the H2O. Okay, previously we injected H2 and O2 both reacted and we formed the H2O. Okay, maximum H2O you can see in the center. Then this is H radical. This shows exactly where is the maximum temperature, where is the core. First one is solver. So here I have taken very low velocity only, just 10 meter per second and 3 meter per second. So I can simulate this with the pressure based itself. If you are going for the supersonic combustion, you should go for the density based. Okay. Then I'm taking steady flow only. Then model energy should be on. Definitely there is a temperature change. Then viscous model. Okay. There is. I am not interested to see how the flow reacted with the wall. Okay. What I'm seeing is generally how the flow mixes inside, how the combustion happen. So for that, this is far field, right? That is wall bounded means you can go for k omega. So here I am taking k epsilon. Then additionally, I should define this species. So in the species, I am taking non-premixed combustion because I am injecting air and fuel separately. Then in this boundary, so N2O2, it will be default, you can find it. Okay, 78% of N2, 21% of O2. Then remaining fuel, what you are taking, that alone you have to define it. For example, I will remove everything. For example, if you type CH4 and remove, that box will be removed. Then C2, the 6, remove. That also will not be there. This jet also, jet. And hydrogen also simply now I will remove it. Okay, now only air is there. Now I have to add the fuel. Okay, so first you can check this list available species. You can see around 553 reactants are added. Okay, so depends upon the combustion process you are taking. You can take any fuel from this. Okay, so you can take methane, ethane, hydrogen, or any other complex species also you can take it. Okay, for example, if you want to add methane, it is CH4. CH4 add, that box will be coming. Then here I have to define 1. Okay, air plus methane. Or you don't want this methane, you want to go for the hydrogen. Simply press hydrogen and add. That box will be added. For that you can give 1. Actually, other things also can be there. It won't affect. For example, you are adding methane, ethane, lot of things. Until you change this 00 to some other value, it won't affect this process. Okay, no need to worry for other fuels listed. Okay, only if you give 1 in this fuel, that will be taken. If it is 00 means it won't be considered. Is that clear? This step, the boundary.
Yes, sir.
Okay, we are defining air plus fuel. Then here you have to define the temperature. So fuel I'm injecting at 300 Kelvin, oxidizer injecting at 650 Kelvin. Okay, so this is the second step. Okay, first non-premixed, second boundary, species I defined, third table. In that table you click calculate PDF table. See, it is calculating, and see it added 11 species. Okay, that is product of that H2 plus O2. 11 products it added. Okay, sometime here I have mentioned 500 553 species, right? You have some other complex chemical reaction if you want to simulate. There is another one add-on for this fluent, that is chemkin. Okay, this chemkin, using that you can create all the reactants, product species, everything using this software, that you can import it in this fluent. Okay, for if you are going for the some research, even major project, sometime masters, PhD, etc., and all, definitely they will go for this chemkin. Okay, okay, now I am just taking already available species in the ANSYS library itself. Okay, so first step is in the model I selected the non-premixed, then boundary, oxygen plus, and that is air plus fuel, mixture ratio, also the temperature. Then in the table, you should not forget, okay, calculate PDF table. So all the species are added. Remaining same procedure. Material, already it is everything added. You can see all the products are added. We no need to change anything here. Then the boundary condition. Here we will define the velocity inlet for air and fuel. So inlet I have taken 15 meter per second. Then thermal 650 Kelvin. Species I don't change it. This is air only. Okay. Momentum 15. Thermal 650. Species 0. And similarly for the fuel inlet, first I'm defining the momentum 7.5. Okay. There I have taken 3. It's okay. Here different value. You can see I'm injecting in the vertical direction. So here it is in Y component. Okay. You should not give in X component. Vertically I'm injecting. So this is the 1. Or if you are defining in any other injection angle, you will put cos theta sin theta here. Okay, so momentum, then thermal 300, and the species, this is must. Mean mixture fraction should be 1. If you don't define, the software will not do the combustion. Simply it will do the mixing of two fluids. This is clear, right? Hello?
Yes, sir. Listening, sir.
Okay. So two inlets, outlet is simply pressure outlet. And then simply you can initialize and run. Okay. I just already done the run for 3000 something. Now we will see the contour. I'll go to the contour, setup. First, let me check the temperature. whether it is increased or not. You can see what I given is 650, 300. For that I am getting 2300. Okay, in the center. That means combustion happen. Similarly, you can find other species also. Okay, species. So we have injected hydrogen. See, initially there is a more volume of hydrogen. Okay, from there only we're injecting. So more hydrogen. Then it is reduced because hydrogen becomes H2O and other products. So you can't find the hydrogen after that. Similarly, you can find O2, H2O, you will see. H2O, okay, hydrogen plus oxygen, it reacted and you can see the red color, that much H2O water vapor is formed. Then OH I mentioned. OH means it shows the what is it, flame core, okay, where is the maximum temperature that it shows defined. So these things you have to add it. That's it.